Okay, chapter five. There we go. Chapter 5.3. This is just a quick recap of the whole chapter. What did we learn? So, first thing we learned was that if you have an extrema in a graph, then the derivative will change sign. So if you're looking at a graph of a derivative, you went from the derivative greater than 0 to the derivative less than 0, or vice versa. If it goes from positive to negative, you have a maximum, and if it goes from negative to positive, you have a minimum. Okay, what's next? Concavity. If your second derivative is greater than 0, then your graph must be concave up. Notice slope of the derivative going from smaller to larger. If the second derivative is less than 0, your graph must be concave down. Again, slope of your derivative going from larger to smaller. An inflection point, which is the change in concavity. The first derivative must exist, so the tangent line exists, and the concavity changes. Doesn't work otherwise. You have to have concave down, tangent line, concave up, because otherwise you could have a situation where you went concave down, concave up, and notice that the derivative doesn't exist there because you've got a corner. So inflection point, this is an inflection point, this is not an inflection point. All right, graphs of derivatives. What do we do with graphs of derivatives? Well, the first thing we're going to do, derivatives, the first thing we're going to do is make a chart. Every time you are given the graph of a derivative, start by making a chart, and your chart's going to look like this. Put on your critical points. Put on your second derivatives equal to 0. And then start analyzing, and then identify regions of positive and negative for both. So once you've identified your regions of positive and negative, these will tell you where your minima and maxima are. These will tell you where you have inflection points and concavity. This will also tell you where your function is increasing or decreasing. And once you know where it's increasing, where it's decreasing, where all the extrema are, where the inflection points are, and what the concavity is, you can sketch the original graph. Now, are you going to know y values? No, but you're going to know the shape based on the x values. All right. Let's see. Second derivative test. Second derivative test tells you that if your second derivative is less than 0, you have a maximum. And if your second derivative is greater than 0, you have a minimum. This test fails for second derivative equal to 0 or does not exist. So then you'll have to go back to analyzing. And finally, what happens if you have a discontinuity in a graph? Discontinuity in a graph of the derivative. This implies that you have a corner on your original graph. All right, that is section 5.3 in our calculus book. Hope you learned something. Have a great day.